A car is going 19 meters per second, jams on the brakes, slowing down to 8.4 meters per second, leaving skid marks 24.6 meters long. What is the car's acceleration? According to our problem-solving process, the first thing we want to do is write down our given information. We want to identify it by the units. So if we look up here, we've got 19 meters per second. Where you see meter per second, that means you've got a velocity. So I'm going to go ahead and write down 19 meters per second here. Now we've got another meters per second, 8.4 meters per second, so that's another velocity. We need to ask ourselves which one is initial and which one is final. So a car going 19 meters per second slows down to 8.4. So that means that the initial was 19 and the final was 8.4. Now we also have this term, 24.6 meters. Anytime you see meters, that's going to be distance. So 24.6 meters. We are solving for acceleration. The units that we're going to use will be meters per second squared, because I've got meters per second and then I've got meters for my distance, so the unit's going to be meters per second squared. I'm going to go ahead and write that here. I'm going to do one more thing, and I'm going to write a negative sign just in case I forget. This means that I'm slowing down, and that way if I do forget, whenever I write my final answer, it'll be there for me. Okay, now we're going to look at the equations that we have to choose from. If we look at this equation, VF squared equals VI squared plus 2AD, we'll notice that we've got VF, we've got VI, we've got distance. We're solving for acceleration. So what I do now, the next thing in my problem-solving process, is that I am going to solve for the variable acceleration. VF squared minus VI squared, all I did was move it to one side, equals 2AD. I'm going to divide both sides by 2D. And that gives me acceleration. Now I'm going to plug in my numbers. I'm going to make sure that I account for my units. So when we're writing it in dimensional analysis form, remember it looks like this. VF squared minus VI squared over 1 times 1 over 2D. All I've done is just rewrite my equation so that I can better account for my units. Now I'm going to plug in my numbers. Acceleration equals 19. Well, actually it's VF squared, so let me redo this here. 8.4 meters per second. I'm going to have to square this, minus 19 meters per second. Square that one. I'm going to multiply that answer by 1 over 2 times the distance, 24.6 meters. Alright, before I do anything with my numbers, I'm going to look at my units to see if I'm ending up with the units I want to end up with. So this term is going to give me, as far as units, meters squared per second squared. Same thing here. Down here, I'm going to end up with meters on the bottom. So my answer, I'm going to be able to cancel out a squared up here where you see meters squared with this meters down here. And I'm going to end up with meters per second squared. Now, is that what I want? Yes, it is, because acceleration is going to be in meters per second squared. Now, I'm going to worry about my numbers. 8.4 squared gives me 70.6. 19 squared gives me 361. So 70.6 minus 361 gives me a negative 290.4. So I'm kind of running out of room here, so I'm going to go right over here. Negative 290.4 divided by 2 times 24.6 is 49.2. So negative 290.4 divided by 49.2 gives me a negative 5.9. So my acceleration, negative 5.9 meters per second squared.